Show that for any triangle, the area can be expressed as 1/2 the product of any two sides times the sine of the angle formed by these two sides. That is, we want to show that the area formula can be expressed as BC sine alpha divided by 2. What you see on the top is the product of the side B times side C times the sine of the angle alpha formed between these two sides BC divided by 2. So now the solution is to start considering three different triangles: acute triangle, right triangle, and obtuse triangle, right? Because we want to prove this formula for any type of triangle. And we know there are three types like that. There's acute, all right, in which the phi angle is less than 90 degrees. As you can see, it's acute. In which it's a right triangle, in which the phi is 90 degrees exactly. It's a right angle. And then obtuse triangle, in which the phi angle is obtuse, right? It's greater than 90 degrees. So now, as you can see what I drew here, first we have to understand that the area formula can be expressed as the base times height divided by 2. Okay, so we can go ahead and write this formula in for the area. So we know the base is a side such that the height is drawn perpendicular to it. All right, and we can see that we can draw a height from that vertex for which the alpha angle takes place there, all the way down so that this height is perpendicular to the base A. Right, so we know A is the base. We can just write A, H1. So notice that the particular height is H1, and it's not the same height as the height that you see here. That's why this is a different height. Okay, so that you're not confused. Divided by 2, right? So we just copy this formula and replace B with the base A because it's labeled A as this side in particular. Right, so now we somehow need to get from here to here. How do we do that? The first thing we want to do, we want to use the law of sines, because the law of sines actually gives us so many different combos of sine of angles, and also it relates the sides with the corresponding opposite angles, right? So it's going to be very helpful for us. So we want to substitute the A with somehow B's and C's existing, right? So we need to involve the A, and the law of sines, of course, is A divided by sine alpha. So A divided by the sine of the opposite angle. In this case, opposite of the side A is the alpha angle right there. So it has to be sine of alpha is equal to, and again, we want to involve C as well, right? And why C and not B is because C is opposite of the phi angle, right? And we want to work with the phi angle, and you're going to see why, right? So C divided by sine phi, all right? Now, if you solve for A, because we want to substitute the A and get rid of it, in terms of C and everything else possible, and you're going to see that we're going to derive B later on, you're going to see that if you solve for A, it's going to be basically the product of C sine alpha divided by sine phi. All right? So now let's substitute that in. So it's going to be what? A is going to be C sine alpha times H1 divided by 2. And also sine phi, let's not forget that. So I'm going to write 2 sine phi. Okay, so now we're getting closer. We already see sine alpha right there. We already see the C, but we're missing the B, and we need to get rid of the sine phi there. Now, how do we get rid of sine phi? Notice that sine phi can actually be found by taking a look at this right triangle. Why do I think it's a right triangle as well, and not just that one, is because you automatically create two 90-degree angles here, right? So we know that this is 90 as well, because this is a straight angle, right? A side is a straight line segment, right? It's not a curve, so that means this is 180 degrees. These two angles make a linear pair, right? So if one of them is 90, 180 minus 90 must be 90 as well, right? So this is a right triangle as well. So that means we can use the regular trigonometry to determine what the sine of this phi angle is. It's going to be precisely opposite side, in this case H1, divided by the hypotenuse, right? The longest side of this triangle, and you can always check it even without using your eyes by noting that this side is opposite of the 90 degrees. Whatever is opposite to the 90 degrees must be automatically a hypotenuse in the right triangle, right? So it's divided by b. So we can substitute those in and see what we get. So what does that give us? That gives us c sine alpha h1 divided by 2. And what is the sine phi? We determined that's h1 divided by b. All right, we're getting closer. So notice h1s cancel out. That's good. We also realize that the b is in the small denominator of the large denominator, which means that that b must multiply the top. Right, so it's going to be basically b c sine alpha divided by 2. We have successfully showed for an acute triangle that indeed this area formula holds, right? B times C times sine alpha divided by 2. Now, let's talk about the right triangle. Okay, so the right triangle, again, we can use the B in this case as the large B, the base, because we know that in the right triangle, the base and height are perpendicular to each other, and the height is already by default A in this case, right? So we know it's going to be AB divided by 2. All right, so now we need to get to that, right? We need to get to that, but again, we already have the A value in terms of the C sine alpha, right? So we can just write C sine alpha times B divided by 2. But also not to forget that there's a sine phi, right? There's a sine phi involved. Now, how does the sine phi work in this case? Notice that the phi is no longer less than 90 degrees. It's exactly 90 degrees. So what that tells me that we actually know what the sine of 90 is, right? Because phi is 90 degrees. So we can just directly just write sine alpha times b divided by 2 times sine of 90 degrees. So what does that give us? B can be put in the front because, you know, multiplication is commutative, right? You change the order of multiplication, doesn't matter, right? So BC sine alpha divided by sine of 90 is 1, right? So it's going to be 2 times 1. Sine of 90 is 1, so guess what that does? BC sine alpha divided by 2. Again, now for the right triangle, we proved that indeed the formula holds. Now we're left to prove that this formula holds for the obtuse triangle, all right, in which the phi angle is greater than 90 degrees. All right, so how are we going to write the area formula here? Notice that the base is taken by C this time. Notice our base has changed roles, right? First it was the A, then it was the B, now it's the C's turn to take the large B in its place, right? So we can just write C times H2, right? Because base times height, the height is perpendicular to the base. You can draw it that way from this vertex, for which the phi angle is responsible. You can draw an altitude or a height that is going to be directly, perpendicular to C. So it's going to be the area is going to be the base times height, C times H2 divided by 2. All right. So how do we go from here? We could just figure out the sine of alpha. Right? We can write the sine of alpha. We can determine the sine of alpha. Okay. So how are we going to do this? We can write sine of alpha. Now again, notice that this is a right triangle as well, because like I talked about here, it's a straight line, right? It's C is a side, it's a straight line segment, such that these two are, make a linear pair. When they make a linear pair, if one of them is 90, the other one must be 90 because their sum must be 180. They're supplementary. Linear pair is always a supplementary sum. Right, so this is 90, so this is also right triangle. So sine of alpha is going to be the opposite side, in this case H2, okay, divided by the hypotenuse. And hypotenuse is always the side, the longest side, opposite of the 90 degrees. So in this case, B. All right, so what does that do? That tells us that I can actually solve for h2, the height, because we want to substitute this h2 with something else that involves the b and sine alpha. Right, so in this case, h2 is going to be basically the product, because you multiply both sides by b to get rid of the bottom. B sine alpha. All right, so B sine alpha. So now we can just substitute that in, right? So the area is going to be what? It's going to be C times B, because H2 is B sine alpha, divided by 2, right? That's as simple as it is. So we've successfully proved that the formula also holds for the obtuse triangle. All right? So all three types of triangles lead us to conclude that this formula is accurate for any two sides BC and the angle between them alpha, and you can relate these three by using this formula to find the area. Thank you so much for watching. I hope this was helpful, and I'll see you in my next videos.